I'm Logan. I'm a computational scientist at Argonne National Laboratory, and I came into AI and workflows through the materials science domain. I'm a materials engineer through my PhD work, so a lot of what I study are on those compute-heavy end of the workflows and how we can use AI to move that towards more of the data end. Shantenu?
Thanks, Logan. Shantenu. Um, Sorry about that. I am trying to figure out what I'll do when I grow up, but in the meantime, I'm working at PPPL, Princeton Plasma Lab, and Princeton Computer Science, and trying to figure out how to think about HPC workflows in this era of AI. Look forward to talking.
Excellent. Thanks, Shantanu. And could we go to the next slide? So the slides we have now are to seed the discussions that we'll be having during our breakout sessions today, and hopefully highlight some of the key topics that we can get into to identify those problems and route forward. So talking about how AI has changed since 2002 can't go without mentioning large language models. And beyond the societal implications and the technical challenges associated with just those models, their impact on workflows has a rather notable impact. The AI models have moved from being something that can be relatively well performed on dozens of GPUs, if not hundreds, to things that in themselves motivate exascale compute. The genome scale language models that I've been adjacent to at Argonne themselves require zettaflops of compute, which now that we have exascale computing is something that can be routinely applied and scaled out to other domains. So even though there's this intergrowing focus on the large models, that's really building on top of the kinds of smaller scale AI that's being used pervasively, such as between laboratories populated by robots, guided by AI, connected into high-performance computing workflows, which are something that have been an ongoing trend that has certainly grown further between 2022 and today. Additionally, beyond the kind of span into reality with AI-driven robotics, another kind of trend that we've noticed over the past few years is the diversification of the number of ways that AI are being used inside of applications. The goal is now far beyond just training the model, and the ways that they're being used are far from only demonstration applications devoted as proof of concepts. AI being used as either a goal to achieve a workflow as an integrated component, or as part of a larger framework of applications created to build a better AI, are now all within a rich domain of available applications. Could we move to the next slide? And even though these varieties of challenges have increasingly diversified, some of the underlying problems, particularly where it comes to AI and workflows, remain. This here is a chart from a paper that my team and I published in SC of 2021, so many years ago, especially in AI time. And some of the challenges that we found are still ones we are tackling today. This chart here is showing the utilization of an HPC cluster, ALCF's theta, as a function of time, where color tells me what task I'm running, shade tells me if the node is actually doing the requested work. And you can see a lot of patches in underutilization. Towards the end of the run, a lot of the jobs don't finish, therefore I mark the node as unused. So we're still seeing these challenges of needing to chunk workflows into smaller bits, and the obligate challenges around workflow performance and latency that come into play. There are challenges around retasking nodes, ensuring that the AI tasks themselves run on the optimal hardware, that data, especially for inference tasks, is routed through high performance channels, are mitigated as where possible. Additionally, being able to exchange the components of workflows is an ongoing challenge, especially for AI parts, especially necessary given the rapid rate at which AI technologies are improving. Could we go to the next slide? And those are the kind of things that we want to talk through both in terms of problems and solutions as we go through today. Some of the trends that we've noticed is a lot of these AI-driven workflows are being built on top of workflow solutions that already exist, that they're being grown on top of data fabrics that are decoupled from the workflow systems, allowing the interchangeability of different components to optimize workflows under different conditions. There have been other venues, such as many different AI startups, that are all allowing for the ability to use AI as a distinct component within a workflow, further building towards that rapid ability to interchange these learnable components. And if we could go to the next slide. Being able to envision what these sort of interchangeable tools could be, what sort of problems they address, and how they can be utilized to really make AI embedded applications realize the capabilities of the modern techniques for machine learning are really something that we want to get into today. So in lieu of time, I won't go through these questions here, but if you join us, Shantenu and I this afternoon, populating these lists of questions further and digging into them together as a community are what we really hope to do. So thank you all for coming today. I hope to talk to you later during the breakout.